Hi, I'm James Montemagno, Developer Evangelist at Xamarin. And today, we're going to take a look at Xamarin Forms and building out native iOS, Android, and Windows apps in C# and XAML. Now, the Xamarin approach to mobile development is extremely unique. We build a shared C# logic backend, all of our business logic, models, view models, RESTful service calls, SQL databases, things that are the same across all the different platforms. Then we give you the tools right inside of Visual Studio to access all of the APIs and design a beautiful native user interface for iOS, Android, and Windows. So you may be wondering, what does this look like? Well, if you're a Windows developer, these things here are going to look pretty familiar. It's the .NET libraries running on the .NET runtime, System.io, Link, XML, things that we know and love as .NET C# developers. Now, when you want to go to Windows 10 or ASP.NET or some other Windows platform, you download an SDK, and you get some new namespaces to play around with. You can think of it exactly the same when you want to go to iOS or Android with Xamarin. You get all that .NET goodness on the bottom, but instead of running on the .NET runtime, you're running on the Mono runtime, the original open source implementation of .NET. Then what we do is we give you 100% API access to every single API in iOS and Android, all in C#. So things like UIKit, MapKit, iBeacon, Core Graphics, everything is available to you. And we don't stop there. We take all those namespaces and we create C# wrappers around them and add C# features like async await, Lambda, link support, events, delegates, things that we know and love as C# developers. And of course, we do the same thing over here on Android. You get all of those Android namespaces available to you. And what's really great is not only do you get every single API, but you get full native performance. On iOS, we do a full ahead-of-time compilation. Compile your C# down into LIL, down into LLVM bytecode. Run that through an LLVM compiler and optimizer, and boom, you get a native ARM binary running natively on an iOS device. Same thing true for Android. We're able to leverage just-in-time compilation, run the Mono runtime side by side the Android Dalvik or ART runtime, creating great native performance with all of your C# bindings and .NET namespaces all intact. Now, when it comes to Visual Studio, we have beautiful designers for both iOS and Android, enabling you to build out all of your applications in one solution and share code with all of your Windows applications too. So truly anything that you could do in Objective-C, Swift, or Java, you can do it in Visual Studio with C# with Xamarin. Now, to get started, it's extremely simple. When you're getting started with Visual Studio and installing, just go to Custom, then you'll just find Xamarin. Select Xamarin, and everything that you need to develop iOS and Android applications will be installed for you. Now, if you already have Visual Studio installed, just head over to xamarin.com/download and use our universal installer to get everything that you need. So that's a little bit how to get started and what the Xamarin platform offers. But we're here to talk about Xamarin Forms, a library from Xamarin that enables you to not only share your back-end logic, but also a shared user interface layer all in XAML for iOS, Android, and all of the Windows platforms. Now, we talked a little bit about the traditional approach with that shared C# back-end logic, and the same thing is true over here for Xamarin Forms applications, except for you can share more code up top and still access every single API in the different platforms. So what's included? Well, you can build out 40+ pages, layouts, and controls from C# code behind or in XAML. And of course, with XAML comes great MVVM type features such as two-way data binding, a navigation system to actually navigate from page to page inside of your shared code, an animation API that uses the underlying core animation systems of the different platforms, a dependency service, and even a messaging center to do pub/sub across different components of your application. Everything that you truly need to get started building great cross-platform native applications. Now, when you start building out these applications, you're going to lay down some pages and then some layouts to host all of your controls. We have everything you need from tab navigation, master detail flyout, carousel pages, and of course just a regular content page. And you can lay out your controls in a variety of ways: scroll views, stack layouts, absolute layouts, grid, my personal favorite, and you can mix and match all these together. And then there's the controls, an abstraction of all the different controls across iOS, Android, and Windows in a nice cross-platform API. Things such as labels, list views, maps, sliders, things that are common across the different platforms. But of course, you can bring in your own custom controls or even customize any of these. And we have a great ecosystem of Xamarin Form partners, such as Syncfusion, Telerik, DevExpress, that are all building charts, graphs, and tons of great controls that you can bring right into your Xamarin iOS and Android apps and Xamarin Forms applications. So what does this look like? Well, we're going to dive into code in just a little bit, but I wanted to give you a short example of building a login page. Over here, we have an entry for a username and an entry for password, all in a stack layout. And then a button that's bound to a login command, which is a method that'll get executed when that button is clicked. And you can see that it has a background color of green associated with it. Now, these are all hosted in a tabbed page. So that means on iOS, we're getting tabs on the bottom with images, tabs on top for Android, and a pivot control over here for Windows. And these are the native controls that are being displayed. Xamarin Forms just gives you that cross-platform API. And what's really great about the XAML, it's the XAML that you know and love, but even enhanced. You can do platform and idiom customization right inside the XAML. So if your designer wants you to tweak something a little bit for iOS and Android, you have a nice, simple API to spruce it up. And you can even do it based on phone or tablet. So let's go ahead and take a look at building our very first Xamarin Forms application. Here I am inside of Visual Studio 2015. I have Xamarin installed, so let's see how you would get started building your very first Xamarin Forms application. Well, you'd go to File, New Project, and you normally see your Windows applications or Office or Cloud, but you'll see some brand new Android and iOS project templates here. Under Android, we have things like a blank app or an Android Wear app, an Apple Watch application, an iPhone, and iPad applications to get started building a specific iOS or Android application. To get started with Xamarin Forms, you'll head over to the cross-platform project template solutions here. And you'll see Xamarin Forms Portable and Xamarin Forms Shared. This will enable you to pick between a portable class library or a shared code project to share all of your code of your application, models, view models, and your user interface. Now, we're going to build out a little application called MyWeather, which is going to go off and find weather for a specific location that I've entered into the application and show us a full forecast. So I've gone ahead and already created this application and built out a little bit of our back end using the blank app Xamarin Forms Portable. So let's take a look at that project solution. Here it is, and let me go ahead and zoom in just a little bit for you, and we'll see MyWeather Portable. This is all of my shared code of the application. It gives me all my references, and you can see I'm brought in some NuGet such as JSON.NET, and a few plugins such as geolocator settings and text-to-speech that allow me to access platform-specific functionality from shared code. And of course, all of my Xamarin Forms NuGet packages have already been installed when you create that project. Now, this portable class library is just like a class library, but can be shared with iOS, Android, and Windows. And this is where all my business logic goes. So we have some models such as weather, some services such as a weather service, and a view model that we'll use in our user interface. The brilliant part here is that we also have the views, which are all of our XAML for Xamarin Forms. So we can see truly all of our shared code logic is right here in one nice assembly. Now, the application MyWeather uses a weather service provided by openweathermap.org. Then we can see I have a few RESTful endpoints that I'm going to hit that can pass in a city or a latitude and longitude. So this hopefully looks like a little bit familiar code that you've seen in the past. For instance, the getWeather method here takes in a city and units, such as imperial or metric, uses our good friend HTTP client, formats our string, and goes off and gets that all asynchronously on a background task. When it comes back, we deserialize the weather root object to start displaying in our user interface. So this is JSON.NET. Now, what's that weather root object, you may be asking? Well, when that JSON comes back, we need objects that we can reference in our code to display in the user interface. So the weather root is hosted all in my models, and we can see things such as weather, main, description, temperature, pressure, min-max temperature. These are different properties that are coming from the JSON that I can display in the user interface. And I've gone ahead and C-sharpified them just a little bit with these JSON properties, so I get a nice readable C# API. Now, the core of a Xamarin Forms application comes from the MVVM approach, so model, view, view model. And the view model is what will be our binding to the user interface. So let's go ahead and take a look at the top here. we have a simple weather view model that implements iNotify property changed. And iNotify property changed allows us to raise events to our user interface when we change our code behind. So if we update the temperature or the model, we can let the user interface automatically bind to it. So we can see a few things here that we'll use in the user interface, such as location. This could be Seattle or Boston or wherever we want to find it in the world. We have a few other things such as is_imperial, temperature, condition, and an is_busy flag. We may use that, for instance, to show a little spinner indicator whenever we're going off on the background to let our users know, hey, we're calling out to the network right now. The core of it here is this I command. And an I command essentially is a way of telling Xamarin Forms through data binding what method to execute when you click a button. So here we can say this is the getWeather command, and it's going to go ahead and call the execute getWeather command. And what this will do is it'll go out and take anything that we've entered, such as if we want to use imperial or metric, and our location, to call off to our weather service to get that weather all asynchronously. We'll come back and grab the forecast that we've seen I've hinted added a breakpoint to, and then we'll go ahead and format that up for temp and condition. So that's our business logic of the application, models and view models and our services. These are things that are shared everywhere. But the core here comes into putting it into the user interface and building our Android and iOS or Windows applications. So every single application starts with a main activity or a main entry point. We can still see that I have an Android, iOS, and a Windows application. And this is because nothing is cross-compiled at all. And you can still write platform-specific code in there. So for instance, going into the main activity of our Android application, we can see that we set a few resources and load our application. And this is the only line of code that you really have to add in your platform-specific project to get Xamarin Forms up and running. And we can see it's app. So let's go ahead and take a look at that. So our app here essentially tells Xamarin Forms where to get started. We're going to create a brand new tabbed page and say our data binding context is the weather view model. And we're going to create two pages, a weather view and a forecast view. And then say that that's my main startup page and put it in a navigation so I have a nice bar on top with specific background color of blue. And that's it. That's where the main entry of our application is. So let's start building out a user interface and let's build our very first weather view. That's going to be inside of our view folder in our shared code. We'll go ahead and double tap that. Now this pulls up a blank XAML page, and I could have gone in and said add, new item, and under cross-platform we would have saw a Forms XAML page, and that's what I've added here. Now we have a stack layout, so we're going to stack some items right on top of each other so we can enter this into the user interface. So the first thing that we're going to do is an entry, and we'll set the text here to a binding of location. There we go. So that's going to be our data binding to that weather view model. So as we enter the location, it will automatically update the code in the code behind. Then we'll go ahead and put a button in here, and we'll say text equals get weather. And then remember that command that we wanted to go ahead and use, the get weather command? We'll do the same binding here to get weather command. There we go. And lastly, let's go ahead and do a few labels to display that. So we'll say label, text, and this will be a binding, of course, to the temp. And we can go ahead and adjust some other properties such as maybe font size. We'll set that to 24, nice and big. And then let's do another one to the condition, binding condition. So see if it's rainy or not. And lastly, we're going to do a little activity indicator. And what that will do is give us a little spinner progress bar on our user interface. So we'll say is visible, and we'll do a binding to is busy. And also we'll do a binding to is running to is busy. Oops. There we go. So we've laid down 5 controls into our user interface. And that's going to be where we enter the location, get our weather, and it's displayed back to us. So again, when I hit get weather command, it's going to go into my weather view model and essentially call this method. And then it will go and get the weather all for me. Now, if you remember back in our app, we also had the weather forecast view. And this forecast view is going to give us a list view of all the weather. I've gone ahead and created that ahead of time. And we can see it's pretty standard. We have a list view that's going to do some data binding to a list of items. When I pull to refresh, it'll refresh the weather for me. And I have a nice little data template to go ahead and display the temperature and an icon of what the weather is outside. Now, to actually get this on a device, there's not much I have to do. We'll go ahead and first run it here on Android, and we've set that as our startup project. And when you have an Android device plugged in, it'll show up right inside of the debug menu, or you can go ahead and launch it right on the Android emulator, any one that you like. So let's go ahead and just deploy it here. And this is going to launch it right onto my physical device that I'll be screen mirroring, and we'll start a debug session right now. All right, the application is launched, and you can see that I have a tab with weather and forecast up top, and I can swipe back and forth. There we go. Now it's defaulted to Seattle, Washington, but I can go ahead and click Get Weather. There's our little spinner, and we've hit our very first breakpoint. Now we've gone already out and gotten our weather route. So here we can see that we have all the weather that we would need to display, the city ID, the temperature, that it's raining, of course, in Seattle, classic Seattle. And then we can go ahead and look at our weather objects. This is classic debugging, just like you've always done. Now we'll go ahead and continue on and grab our forecast. And this has gotten a full 5-day forecast of all of our points in 3-hour intervals. So you can see all of the items in the list. So let's go ahead now, and we'll go ahead and just continue on. And there we go. It's raining, of course, in Seattle, and it's about 48 degrees. If I go over to the forecast, we can see the forecast here in Seattle, and of course, rain every single day. Classic Seattle. Oh, it looks like it's going to stop. Now, this is beautiful material design that we have coming in with material tabs, but let's go ahead and see what it looks like on iOS. So I'm going to go ahead and stop debugging and set iOS over here as my startup project. And we'll notice that it's switched over to iPhone Simulator as my target. I could also select an iPhone to debug on a physical iOS device. And it's gone out and connected to my Mac to pull all of the iOS specific devices that I can launch on. So we're going to go ahead and build this up. With it all built up, we'll go ahead and start without debugging. So here we go. This is going to start up on my iPhone 6s. Now, even though I'm here inside of Visual Studio, I'm connected to my Mac and actually showing it right here. So we can see that I'm actually on a Mac, but inside of VMware. Here, now we get tabs on the bottom for weather and forecast, and I'll just go ahead and say Get Weather. There we go, and of course, light rain. Let's pull back up our Android device so we can see kind of the difference here, as we have not only different material tabs, but still the same styling, but we're getting the iOS look and feel because it is an iOS application. I can select forecast, and of course here I have my full forecast. I can go over, pull to refresh, same thing true on Android. I can go ahead and pull to refresh here. There we go. Now, because this is a Xamarin Forms application, we can target not only iOS and Android, but any of the Windows platforms. So here I have a Windows 10 Universal project, and we'll set that as our startup. And again, there's not very much different in our application. We just bring in our shared code, and all of our NuGets, such as Xamarin Forms, and our Xamarin plugins, such as Geolocator and Settings that we could use. And then in our code behind of the main page, we'll go ahead and simply set and load the application. So now, we could run this in any emulator or device, specifically for Windows 10, and we'll just run it locally here on the machine. So let's go see what that looks like. And here we have it. Let's go ahead and pull up all three side by side. I'll go ahead and say Get Weather. And again, still raining. And take a look at our forecast. With 100% shared code, we have a beautiful cross-platform application for iOS, Android, and Windows 10, all built completely with C# and XAML. We just saw how to build our very first application with Xamarin Forms. Now that just scratches the surface, because there's a whole lot more. We've recently introduced Xamarin Forms 2.0, which adds full Windows 10 UWP application support, control templates, data template selectors, gestures such as pinch and pan, XAML compilation, effects, and Android material design, really fleshing out the entire story for building great cross-platform native applications for iOS, Android, and all the Windows platforms. Now to get started using Xamarin Forms, we have great documentation, but you can also grab the free ebook by the one and only Charles Petzold, available on a plethora of different platforms, completely for free. Just head to bit.ly/Xamarin Forms book. Now, if you want to get started and learn more about Xamarin, just head to Xamarin.com, and you can find all of the source code on my personal GitHub, and follow me, of course, at James Montemagno on Twitter. And thank you so much.
Hi, I'm Donna Malieri. I'm a program manager on the Azure App Service team, and today I'm going to talk to you about how you can build great cross-platform, enterprise-grade mobile apps using Azure App Service. In particular, I'm going to show you how you can make your app both responsive and resilient to network connectivity problems by using a feature called offline sync. So let's get started. First off, let me talk about Azure. Now, a lot of people, when they see this slide, they get a little nervous because they think they need to know everything that's here. And the fact of the matter is you don't. New services come out constantly, and I can tell you that even members of the Azure team have a hard time keeping track of what's new. The cool thing is that most of these services work independently of one another, even though they do provide additional benefits when they integrate. So if you take a look at this chart and you see one or two services that you might be interested in, you can learn more. And don't feel like you need to understand everything before you can start making use of Azure for your application. And basically, use what you need, and you only need to learn what you need to use. Today I'm going to talk about the so-called app platform within App Service, which includes web apps, API apps, mobile apps, API management, and notification hubs. In particular, I'm going to show you an app that has both a web client and a mobile client, and it also has a web job that it uses to do background tasks. So let's get started by taking a look at the capabilities that you get with App Service mobile apps. So this chart might be familiar to you if you're familiar with mobile services. In fact, we have the same sections on the right. You have your data connections. We've added some new ones. We have on-premise data connections now, including connectors with Salesforce and Dynamics. And we have a DocDB access, for instance. Authentication is handled the same as usual, and push notifications as well. A new feature that we've had relatively recently is offline sync. And the way that works is that you can sync whatever data source it is that you've configured for your mobile backend to your mobile client. And we have data sync available for all of our client platforms, with the exception of Cordova, which we're working on. So essentially, your client can abstract away knowledge of the underlying data source. So you could write your app connecting to a SQL Server, for instance, and then later change it to connect to Salesforce without ever changing any of your mobile client code. Now, a change that we made recently within the last year when we introduced App Service Mobile is to change the underlying compute that you use for your mobile backend. What we heard from customers was that they liked the flexibility that they got with mobile services, but they wanted more control over the compute container. We tried to make things easier by abstracting that away, but customers said, no, I actually want to be able to manage all of this. So now, with App Service Mobile, your backend is just a regular Azure web app, which was formerly known as an Azure website. So that means all of these great features that web apps has had for years and is continuing to innovate on are available to all mobile backends. So that includes things like Traffic Manager, VNet, App Service environments, and continuous integration and deployment. So I'm going to give you a couple of customer examples of some really cool apps that people have built that really unleash the power of Azure Mobile and make it so that they can focus on their app code rather than focusing on their infrastructure. So if you've ever traveled with Alaska Airlines, you may have used their mobile app. Now, they also have a huge number of employee apps. One such app is Hopper, which is how employees of Alaska, including flight attendants who need to travel for work, how they actually find spare seats on flights, and they can go from one destination to another. And they need their own system because they're not obviously paying for a ticket, and they need to see what flights are available. And they had an app for this before, but it used just regular classic ASP. It was not a responsive app. It didn't work offline. It didn't work on a mobile device. And it also had a lot of missing functionality. So a group of passionate engineers at Alaska said, hey, I bet you we could rewrite this and make it way better. And if we use Azure, that'll really boost our productivity. And so that's just what they did. They built this great Xamarin app that has fantastic internal reviews. And they use Azure Mobile, and including notification hubs, and connecting onto an on-premise data source in order to deploy this app. And they really have a lot of great things to say. If you want to learn more about this, check out the videos from last year's AzureCon, where they actually have some videos showing how they built this app. Now, you can also have consumer apps. There are a lot of great ones that run on App Service. One example is the NASCAR results app that has a tablet version and a mobile version. And this app is interesting because it uses a lot of different Azure services, such as our New Relic integration, which is available through the Azure Store, and of course Xamarin, which is very popular for mobile apps. And I'll show you a demo with Xamarin in just a moment. They use Redis, Microsoft SQL, and MySQL. And their website actually used PHP, which shows that Azure supports more than just .NET. Now, one more employee app, since that's the more common employee enterprise scenario that we're seeing lately, and that is the Transport for London fault reporting app. Transport for London is an organization that manages all of the transit in London. So if you've ever visited London, you've taken one of their services. Now, with a city that large, there's going to be issues that arise. There could be potholes, there could be some power line that's causing a problem for a bus, that kind of thing. And in the past, employees had to either track things down on paper and then enter them into a computer later, or carry around a heavy laptop to record these issues, because the issues need to eventually go on to some on-premise system. So what they've done is they've written an iOS native app that works offline that allows employees to take photos of issues, and this gets submitted back to an on-premise system. So in the case of Transport for London, they didn't want to move all of their existing infrastructure to Azure, but they did want to take advantage of these great offerings that we can give them, particularly in the case of mobile development. So they're using app service environments and VNets in order to securely connect back to their on-premise system. And these are just some of the examples. If you go to azure.com, you'll see that there's even more examples, including the very popular jet.com, who are hosting their mobile site on app service. So the key thing to summarize that Azure App Service gives you is a fully managed platform. It really delivers on the promise of PaaS that we heard, when the cloud came out, but it's taken time for these services to mature, and over the past several years, Azure App Service has really come into its own as a fully managed platform. The other great thing about it is you don't have to rewrite your code in order to run an app service. You just write your code the way you normally would, a PHP site or an ASP.NET app, and you deploy it. You don't have to use a custom programming model. At the same time, you get all these great DevOps features like continuous integration and deployment, load testing, and you also get these enterprise features like VNet integration, Azure Active Directory integration, and so forth. So developers like writing code, but most developers don't want to focus on infrastructure and servers. They want to focus on application code. And app servers really frees you up to be able to focus on your app and what it does that's special, not a lot of boilerplate. So let me show you a demo of a really simple app that has both a web client and a mobile client that we've built with Azure App Service. So let me switch now to Visual Studio. And here you can see that I have a Xamarin Forms app. It has targets for Windows Phone, Android, and iOS. And I'll be demoing the iOS version of this app. So let me show you the mobile version of this app. This is a really, really simple version of, say, Instagram. Like really, really bare bones. Doesn't have filters, it doesn't have tagging, but allows users to share photos. You can use social authentication or Facebook authentication. And you can upload images that are either shared or private to a user. So if we go to the web client, we can see some of these images that we've already uploaded. Now on the right, you can see there's some links to load different size images. And the way that that works is that when you upload an image from either the web or the mobile client, we have a web job that runs in the background that looks for a message that's posted to a queue. And when it sees that message, it loads up the blob and it does an image resizing algorithm in the background. And you can run this web job either on the same site that you're using to host your web and mobile backend or on its own site. And I'm not going to show you the code for this web job, but this entire project is open source and available in the Azure Samples repository. So now let's look at the mobile version of this. So now in this case, I'm logged in using Facebook. And so I see, in addition to the default album, I see a new album called Cat Photos, which I haven't added anything to yet. So let me do that here. This is my cat. And it's taking a little while because it's uploading this image. And now it's uploaded. Now, if I click on these buttons, you can see that the image size is not available yet for the different sizes. The reason is that we are not synchronously resizing this image. Otherwise, that would make the mobile client wait, which would be kind of silly. Instead, when the image is uploaded, the client sends a message to an API, and then an item is added to an Azure queue, which the web job then listens for. Now, I talked about offline sync being a very important piece of functionality, particularly because you don't necessarily always have network access, or sometimes maybe you just want to limit the amount of data you use. And at the very least, you want an app that's very responsive. So as soon as it starts up, it should load the data that it loaded previously and not make the user wait. So let us simulate an offline scenario. In fact, let's completely take off the network. And so this means the simulator also has no network. And if we try to sync here, what we're going to see is it can't work. It can't sync your offline. So, however, we've just taken this really awesome cat photo. And so it's critical that we upload it as soon as we can. So again, it's showing a message because this app assumes that you're online. It's just saying, hey, just so you know, you haven't uploaded this image. And this image doesn't show up here because it is always using what's actually been uploaded to the server. But the image is still loaded into the app. So all I have to do is turn the Wi-Fi back on and pull down to refresh. I can do that from either the main view or the cat photos view. Now we can see that the cat photo is indeed uploaded. And if we were to do the same thing, but add to the default album, let's do this photo instead, we would see the same thing. So let me turn the Wi-Fi back on and sync it again. And now the image is loaded up. And let me go to my web client because I have to go to the default album. Let's refresh this page. And we will see, and here I'm not going to bother signing in. So here we will see this new image. Here we are. Now, the image resizing has kicked in, and the web job has run and resized the image. Let me show you the code briefly for this to show you how easy it is to set up both offline sync and this new feature of uploading images and any kind of blob data, actually, even when the user is offline. So first, what you need to do is have a mobile service client. You use our mobile client SDK. Here I'm using the one for Xamarin, but we have it for Android and iOS, as well as Cordova. And we create a SQLite store, which is how we're going to actually store the structured data, not the image data, but just the structured data. And then we create some local tables. Then we create sync context, which is essentially tracking all of these changes that we made while we were offline. And the other thing that we're going to do is set up the local store so that we get callbacks whenever there are local or server operations. And this is a new feature that we've added with our file sync support. And it means that you can either write your own code that synchronizes in the background and refreshes the UI by listening for these callbacks. Or in the case of the file sync API, this is how it actually finds out that there are new records, and then it makes queries to the server to find out what images are associated with them. In order to actually sync, it's super easy. You just push both the file changes and the regular changes and pull the albums that you want. In addition, when you're using file sync, you're going to want to write a file sync handler, which again is also really simple. You set a file data source. In this case, I'm using the dependency service pattern in Xamarin, and so I have a simple class that just loads different classes to actually load the image from the device, since that is platform specific. And then a file synchronization action is going to get triggered whenever there is a change to a file. So that's why that listener is being used. It triggers this callback. So here, if you are, in the case of delete, we're going to delete the file. Otherwise, we're going to download the file. And that's how it works. And the key there that I showed you was offline sync. And the reason is that nowadays you can't always assume network connectivity, and users are expecting more from their apps. Even if they aren't some app that's critical to work functionality, people want to be able to use them and sync data later. The problem is that the reason that most apps don't have offline sync is that it's usually really hard to get this functionality to work. It's relatively easy if you only want read-only data, but as soon as you start changing data, and the data can be changed by multiple people or even just multiple devices, then the problem of doing sync becomes really hard. And so in the spirit of app service, in order to let you focus on your app code and not boilerplate and infrastructure, we have these client SDKs and server SDKs to make this super easy. So the reasons for doing offline sync are basically what I said. It could be just as simple as making your app responsive, or it could be the most interesting case where you have multiple users editing the same data, but you want to make sure that they don't stomp over each other's changes. So we also include conflict handling. So the way it works is that the client SDK, the offline sync feature of it, keeps track of all the changes that are being made when the app is offline, and it saves these to a queue. And then when the app detects that it has network access again, in the case of the app I was showing, it always checks for network access. And so the sync action is triggered by the user actually pulling down to refresh. At that point, the app calls the push and pull methods. And what push does is it finds all these changes that were in the sync context, and it sends them one by one to the server, ensuring that the operation is preserved. You can also use this feature in conjunction with Azure Notification Hubs and have your server actually send silent or raw push notifications to the client so that the client wakes up and then downloads data. And you can even do this in a background task so that the app always has the freshest data. So to summarize, what App Service does is that it provides the infrastructure so that you can run your mission critical or even not so mission critical web and mobile apps. You can have these apps scale with your business. You can start out small with the free tier and scale all the way up to hundreds of instances that run in an app service environment. So let us do the infrastructure and you can write your app. Thank you very much.